Let's talk some geometric sequences, huh? So a sequence is a set of numbers, and they're going to have a pattern. So an arithmetic sequence we talked about earlier in the year, or arithmetic, it is when you are adding the same amount as you go down the line. Geometric sequences are where you're multiplying by the same amount each time as you go down the line. Now that number that you're multiplying by is called the common ratio. So if you look at this first example, 3, 12, 48, 192, that one might jump out at you. What are you multiplying by as you go down the line here in this pattern? From 3 to 12, you might be like, hey, that's times 4. And is 12 times 4 48? Yeah, it is. 48 times 4, 192? You bet your face it is. So that would be the common ratio. Now maybe that number didn't jump out at you. Or maybe you struggle with finding factors and doing multiplication. Fear not. Ha ha ha. There's another way. You could take any term and divide it by the previous term. If you did 12 divided by 3, it's 4. If you did 48 divided by the term right before it, 48 divided by 12 is also 4. 192 divided by 48 is 4. Great. Now you might look at this set, 80 to 20 to 5 to 5/4, and you'd be like, great, we're dividing by 4. Cool. But we have to write it as multiplication. So dividing by 4 can be written as times 1/4. So our common ratio on this one would be 1/4. But again, what if you couldn't immediately identify that? Is there another way? Is there another way? Yes, I just told you. You could take any term and divide it by the term right before it. So if you took 5 and divide it by the term right before it, 5 over 20, you just simplify that fraction and it's 1/4. Or if you did 20 divided by 80, that also simplifies to 1/4. That's probably the faster way that you can do it. Take any term, divide it by the previous term. So if you were to do that here on A, and again, it works for any of them. Let's take 6, and we'll divide it by the term right before it. 6 over 30. That reduces to 1/5. So that would be our common ratio. So again, it's like you're dividing by 5 when you're multiplying by 1/5. So you could check in your calculator, 750 times 1/5, or divided by 5, and it's 150. If you divide that by 5, it's 30. If you divide that by 5, it's 6. So we're multiplying by 1/5. Let's try this one. Again, this might jump out at you right away, but let's pretend like it didn't. You take any term, let's say we took negative 12, and you divide it by the term right before it. Negative 12 divided by negative 6 is positive 2. So that would be your common ratio. And let's try C. And let's just do 4 divided by, or 6 divided by 4. Now you could do decimals, but we're cooler than that. Let's reduce 6 over 4. They're both even, so we could divide them both by 2. That would leave us with 3 over 2. Koala. So that's the common ratio, the number you're multiplying by. Find the next 3 terms of the sequence, 2, negative 6, 18, negative 54. So we're going to want to find the pattern. What are we multiplying by? What's that common ratio? And we can do what we just did. Let's say I took negative 6, and I divide it by the term right before it, 2. Gives us negative 3. So our common ratio is negative 3. So each time we're multiplying by negative 3. That looks like x minus 3, but I meant times negative 3. So if we kept that going, negative 54 times negative 3 goes to positive 162. I'm going to multiply that by negative 3, and I get negative 486. I'm going to multiply that by negative 3, and I get 1458, which happens to be the year my grandfather was born. All right, find the next 3 terms of each sequence. 1, 3, 9, 27. You might not be able to easily figure out what you're multiplying by, but we could take any term, divide it by the term right before it. 9 over 3, that's 3. So that's our common ratio. So we're just going to keep multiplying by 3. 27 times 3 is 81. Times 3 is 243. Times 3, I don't know that one. 243 times 3, 729. Ah, yes. All right, this one's a little trickier. We take any term, let's say we took negative 15. We divide it by the previous term. 15 goes into 30 twice, so this fraction, the common ratio is negative 1/2. So we have to keep multiplying by negative 1/2. You can use decimals, negative 0.5. So negative 15 times negative 0.5 is positive 7.5. Sorry. 7.5 times negative 0.5 is negative 3.75. And if I did negative 3.75 times negative 0.5, 3.75, I get 1.875. All right, last one. Look at that pattern. 1.1, 2.2, 4.4, 8.8. We're multiplying by 2. That's our common ratio. So we can keep that going. 8.8 times 2, 17.6 times 2, 35.2 times 2 will be 70.4. Fantastic. Look at us just having fun. Oh, geometric sequences, you're a true delight. Determine whether each sequence is arithmetic or geometric. Are we adding the same amount or are we multiplying the same amount? No. Look at that A. Negative 7, negative 5, negative 3, negative 1. They're all 2 apart. So we're adding 2 each time. So that would be an arithmetic sequence. We'll just put an A there. Now this one, well, I see that 56 and 28, those are 28 apart from each other. 28 and 14 are 14 apart. 14 and 7 are 7 apart. So they're all different numbers that we're adding. So it's definitely not an arithmetic sequence. Let's see if it's geometric, or maybe it's neither. If we took a term and divided it by the previous term, 28 divided by 56. If I just did that in my calculator and I didn't know how to simplify fractions, that comes out to 0.5. I would want to make sure that all of them come out to 0.5. So if I did 14 divided by 28, yeah, that comes out to 0.5 as well. 7 divided by 14, they all come out to 0.5. So that's a geometric sequence. We're multiplying by 0.5. We're multiplying by 1/2. That's our common ratio. 2, 4, 6, 8. Who do you appreciate? We're adding 2 each time. That's an arithmetic sequence. But 2, 4, 8, 16, that one we're multiplying by 2 each time. So that's a geometric sequence. And then look, 1, 3, 5, and 7, they're all 2 apart from each other. So that's an arithmetic sequence. All right, one more type of problem. Find the first, fifth, and 10th terms of the sequence that has this rule. So this is like a general rule. If you look over here, the first term is always out in front. So in this case, the first term is going to be the 5. The negative 2 is that common ratio. It's what are you multiplying by each time you go down the line here. And then the exponent's always going to be n minus 1, the term number minus 1. So when we're looking for the first term, we're just going to do, we're solving a function here, man. So we're going to, for the first term, we're going to say a of 1 equals, and we're substituting these numbers in for n. So 5 times negative 2 to the 1 minus 1 power. Now, if you just simplify the exponents, 1 minus 1 is 0. Anything to the 0 power is 1, so this just becomes 5 times 1, which is 5. So our first term in that sequence would be 5, which makes sense, because the number out in front is always your first term. Now we're going to find the fifth term, a of 5. 5 times negative 2 to the n minus 1, 5 minus 1. So 5 minus 1 is 4. Negative 2 to the 4th power. It's in parentheses and it's negative, and it has an even exponent. That means it's going to come out positive. And 2 to the 4th is 16, and 5 times 16 is 80. So the fifth term in this sequence would be 80. And then we would need to find the 10th term, a of 10. 5 times negative 2 to the 10 minus 1. 10 minus 1 is 9. Negative 2 to the 9th has an odd exponent So it's going to come out negative. It's negative 512. We still have to multiply by 5. Negative 2560. Cool. I think we got 2 more of those. Same type of problem though. Find the first, 6th, and 12th. What? Now check this out. Remember, the first term is always the number out in front. So our first term on this one is just going to be 4. Our first term on this one is just going to be the negative 2. We don't even need to do any math for that. Look, the first term shows up out in front. Now, the 6th term, we're going to have to do some work. A of 6 equals 4 times 3 to the 6 minus 1. I bet we could do that with no calc. 6 minus 1, that's 5. No, I don't remember what 3 to the 5th is. 243. We still got to multiply it by 4, which gives us 972. All right, that was tough. Now we're going to find the 12th. A of 12. 4 times 3 to the 12 minus 1. That would give me 4 times 3 to the 11th. 311. 3 to the 11th, huge number. 177,147. We still got to multiply that by 4, man. 708,588. Wow. Wow. Oh, wow. All right, now to this problem. We already did our first term. Now we're going to do our 6th term. A of 6 equals negative 2 times 5 to the 6 minus 1. That'll be 5 to the 5th. Again, I don't know that number. 3125. Negative 2 times 3125, which will give us negative 6250. And now we're going to find the 12th terms. We're going to sub in 12. A of 12 equals negative 2 times 5 to the 12 minus 1. Negative 2 times 5 to the 11th. Whew, that's going to be gigantic. Holy cow. 488 28125. 48 mil times negative 2, negative 97,656,250. Wow, what a way to end the notes with a ridiculous number like that. Ridiculous.